Yeah, it's Friday, and I'm thinking I'm back because we're talking about John Wick. More specifically, what is inside John Wick's bulletproof suit? Well, what makes something bulletproof? You would want some kind of material that resists penetration from some projectile. It doesn't have to be completely rigid, it doesn't have to explode a bullet, it just has to prevent that bullet from going through the thing. In this case, Mr. Wick. Now, what is inside his suit specifically? Well, we know it's probably not something like Kevlar. So if you haven't seen John Wick, in number 2, I believe they introduced the concept of a bulletproof suit lining, which is very, very, very thin. It can go into your suit so you don't have to wear a bulletproof vest. Traditionally, we wear bulletproof vests for bulletproof things because it has a very high ultimate tensile strength. And what's in a bulletproof vest and has that ultimate tensile strength is Kevlar. Now, Kevlar is a synthetic fiber that we created, and it is very light, and it has a high ultimate tensile strength. And when I say that, I mean that it is good in tension. If you were to take a fiber of Kevlar and stretch it, try to pull it apart, it would resist you quite a bit. You'd have to put a lot of energy into it in order to make it experience that tension force. So that is why we use Kevlar in bulletproof vests. For example, if you had a bullet flying in towards some patch of Kevlar, as I have illustrated here, the Kevlar will bend. Well, it will attempt to stretch under the strain of the bullet. Now, that will cause a tension force here. If you have a material that doesn't have a high enough ultimate tensile strength, this material will fail and the bullet will go through it, rip it apart, and go into you. If this was just paper, for example, it would not be strong enough to stop the bullet. When we use Kevlar vests, we use them because they're very strong in this orientation, and they are very light, which means wearing them is easier than wearing the similar thickness of like a steel plate or something. Now, for John Wick's vest, or his bulletproof suit rather, what would have to be in it? Well, if you want to make something that's very thin, obviously he's not wearing like a bulletproof suit that is like a bulletproof vest. It's all thick all the way around. He would look like he's in the bomb squad and it would look kind of silly. It has to be very thin. If you want to make a very thin bulletproof material, then you have to up this ultimate tensile strength even more. And right now, the only things that are close to being mass-produced, that are as strong in tension as Kevlar is, are things that involve carbon. Like graphene, you may have heard of this amazing material called graphene, which is basically single layers of carbon atoms, or carbon nanotubes, which I'm sure you've also heard of. Now, there are companies and researchers around the world that are trying to work with graphene and carbon nanotubes and weave them into fabrics to make them a part of fabrics and give them incredibly high ultimate tensile strengths, and they then might make some kind of bulletproof, ultra-thin, like dress shirt or dress jacket or something like that. However, I will say that all these applications right now are in the future. Aside from research, aside from experimentation, these things are not being mass-produced. It's hard to make carbon nanotubes, and it's hard to make a lot of them, and graphene is weird and expensive. So, right now, making John Wick's bulletproof suit is probably a little bit outside the realm of real tactical possibility. However, if there are enough assassins in New York that every single person, seemingly every other person in New York and in the world is after John Wick, if they have that access to resources and all they do is kill people, could they eventually experiment and create something that has a very high ultimate tensile strength, some kind of material that's a composite material, and weave it into suits? Sure, maybe. I will point out, though, before we get to your questions, that although a very thin material would stop penetration, would absorb the kinetic energy of the bullet going into tension like this as the material deforms, it prevents penetration, but it does not prevent the momentum change from the bullet. So even if you are not getting shot through, you are still going to get extreme bruising. Maybe if it hits you in the chest, you could have cardiac arrest, break a few ribs. But at least you will not be, put on his list. So, hello and welcome to another edition of Because Science Live, the version of Because Science, where I try to take all your nerdy comments, questions, and weird comments about my appearance off the top of my head and give a little insight into them. Look, I'm not an expert. I'm not a working scientist, but I do know a little bit about a lot of sciencey stuff, so if you have any nerdy questions for me, I can probably point you in the right direction or say something halfway interesting. Also, in honor of our new show, our new expansion show, Because Space, which has its first episode on Monday, I have another special guest with me this week, Dr. Moo.
Hey, Kyle.
Hey, Dr. Moo. Oh, I love having you here. You're so excited. And we're wearing the same color.
You know.
We didn't coordinate this.
We did not coordinate this.
And Dr. Moo is a space expert. She works in the field and she knows what she's talking about. She has a PhD. It's more than I got. So if you have any spacey, sciencey questions, especially for Dr. Moo, hit us up in the chat. Do not spam the chat or else I will never answer your question. But if you have something nerdy, sciencey, spacey, hit us up and we will get to it, hopefully. I got Voice of the Void Nate here somewhere.
Yeah, I'm here. I'm around.
Okay. You always say that, but that doesn't
That's all
really...
you're ever going to get.
Okay. So what do we got first?
From Esteban Benitez.
Hello, Esteban.
What is the core of a gas planet like, i.e. Jupiter or Saturn?
Good question.
Ooh, that's a really good question.
Does this have an answer?
Not really. I mean, there are scientists that are really geared toward understanding the gas giants, the planets, a lot of planetary scientists, of which I am not one. However, there's a lot of great experiments, missions, satellites that venture to places like Jupiter, other gas giants that really help us to understand. So I'm not 100% sure, or not even 10% sure. Check the websites for Cassini, check it for all of the NASA missions, and definitely tweet and message your favorite planetary scientist. Thank you.
Need that at some point. I forgot about that. You'll get us copyright stricken. As far as I know, something like a gas giant like Jupiter. The problem with trying to figure out what's in its core is getting to the planet itself. So not only do you have to make an incredibly long and difficult journey to it with a robotic, mission or something like that, you'd want to probe the depths of the planet to see what the core is like. The problem there being is that there is so much pressure in the atmosphere of these gas giants. There's so many gravitational force. It is a very inhospitable environment to living things, especially, but robotics too.
Yep.
If you were to just dip a spacecraft into the atmosphere of, say, a Jupiter, it would be destroyed pretty quickly, I believe.
Oh, yes.
So getting to the core of something that is just gas isn't easy just because it's gas. It's very, very high pressure gas that will rip stuff to shreds. I think there's speculation that it might be a rocky core at the center of something like Jupiter, but we just don't know. That's why we need to send space missions, as Dr. Mood said. What else we got?
From David Matthews.
Dave Matthews is asking a question? Do you know what would be good? If Dave Matthews was asking a question about sending a satellite to this place.
Of all the questions science still has about the universe
Oh, you're just skipping
and
that.
everything in it, which question would you most like to know to answer to?
What question would you like to know? I think that was Dave Matthews. I don't know. What science question would you most want to know the answer to?
My ultimate question that I would love to know the answer is, are we alone? The search for life.
Either the scariest thing or either way it's scary, if we're alone or we're not alone, right?
Exactly.
Someone smart said that sometime.
Yeah, somebody said
That's
that.
what you want to know?
Yeah.
I mean, the question of life in the universe is obviously like the grand question, right? It would be the most important discovery that we've ever made. And you think of all the knock-on effects that would have if we knew that we weren't the only organisms in the universe. Not only would it be very scientifically interesting, but it would radically reframe our position in the universe. And science has done that time and time again. Everything doesn't revolve around Earth and us. We're not the top of the food chain. Evolution isn't trying to get to something like us. We keep finding out that we're just kind of mediocre in the universe. So finding aliens would be amazingly reframing like that. And just think of all the political and sociological effects of that. There's an awful lot of ideologies that say we are the best thing and the only thing. So, so I can't say that question. What I want to know is Nah, I mean, that's my answer too, I guess.
Yeah.
Oh, sorry.
No, it's fine. It's the big one. I mean, it is the big one. That's what I want to know. If I was omniscient, that'd be the first thing I asked, probably. Also, how many steps have I taken in my whole life?
Oh, wow.
I mean, I can probably average that out.
Yeah, you got that.
From
You're
T
right.
Snow Crash,
You're right.
is genetic mutation like we see in the X-Men even remotely possible in real life?
Interesting.
You want to? Yeah.
Well, you said yes, so go ahead. You seem much more confident than I would seem.
Oh, no. I mean, we're doing this all the time on the microbial scale. There are genes that called, for example, green fluorescent protein. It's this protein that you can splice into DNA, and whatever you splice it into, it glows fluorescently. So you can imagine that if you isolate the right series of genes and proteins that'll allow you to have some sort of cool function, of which most of the things that we have in our DNA, we don't know what they're for.
That's true.
It's possible. Why not?
Yeah, I mean, and I can look. We've made transgenic animals. That is to say, we've taken genes from outside of organisms, put them into organism embryos that they're not usually found in, and then they express a weird a more X-Men-y kind of mutation, like making a kitten glow in the dark. We've actually done that with jellyfish proteins, I believe.
Yeah.
But could an X-Men style, activating a mutation latent in your DNA, is that possible? I think sure. I think epigenetics, the field of what's called epigenetics, is studying how to turn on, turn off certain genetic switches, like light switches on and off, in your DNA and see what happens in organisms. But I do not think it would produce a radical change, like all of a sudden you can control fire.
Agreed.
Yeah, there isn't just a superpower waiting in your DNA. It is more it's like a trail of stuff that worked and a lot of junk that was crafted through evolution and natural selection over millions and millions of years. At no point could you fly, and then that was not selected for anymore,
Yeah.
and it was in there. So if you had something like a Chickenosaurus, so Jack Horner, one of the biologists who inspired the main character of Jurassic Park, he wants to go back into chickens, turn on, turn off certain genetic switches, and have them re-express things that they lost over time, like teeth and like a scaly tail, like a dinosaur, because birds are dinosaurs. There's nothing like that in our genetic history that would suddenly make you turn into ice,
Yes.
probably. So it would have to be a radical change, and I think that would be taking gene splicing, gene therapy, doing something to you rather than activating something in you, because that implies that we had that at some point, or there's a potential for that, and we don't see that in any lineage of anything.
Yeah.
I would want electric eel cells if that were the case.
Ah,
Yeah.
I don't know what I get.
Yeah, shocking answer, I know. What's next?
From George Easton, what would happen theoretically if you took, say, 1 cubic meter of neutron star material and placed it the center of the Earth? Would the planet explode or absorb it?
Ooh.
Highly technical question. So I'm going to draw a cube while you give the answer.
Oh, wow. Thanks, Kyle. That's great.
No problem. That's what I'm here for.
If you were to take a cube of this very dense material and put it in the middle, in the core of Earth, so as you know, our Earth's core is essential to our magnetic field, to sustaining our entire planet, to keep, you need the magnetic field to keep our atmosphere. You need everything. As soon as you change one thing, the dynamics are completely thrown off.
That's what happened to Mars, I believe, right?
Exactly.
With the declining magnetosphere, and then the solar wind blew its atmosphere into space. Yeah, gave it like a mohawk-looking thing in magnetic field. Anyway.
Which is why it's really cool for the next robotic mission. They're going to look for rocks in the magnetic field that's buried, that's kind of like it's frozen in time, so that they can understand what the magnetic field looked like.
Sure, the orientation of atoms magnetically in rocks, kind of frozen in the development of those rocks. Oh, are all these magnetic moments lining up this direction, then that direction, then this direction? Over time, it would give you an idea of when they shifted and.
Exactly.
Anyway, yeah.
But if you took this fancy box that Kyle drew of neutron star dense material.
This would weigh more than a mountain, by the way.
Facts.
Yeah, if you had that much neutron star material, it would go. And I dropped it because I somehow picked it up. It would weigh more than a mountain. It would be denser than anything on Earth. It would sink towards the core of the Earth anyway. And then but it would explode before that. So what people, I think when people use this neutron star example, what we're not remembering is that neutron star material is the densest stuff in the universe that we know of, like material. Black holes would technically be denser, but they're not really like stuff.
Yeah.
It's more like a rip in space and time. So this is like the densest stuff in the universe. It's basically just atomic nuclei. It's so dense because it is being forced by the gravity of the star to be that close together. Now, if I took this cube out and I brought it to Earth, well, the instant I removed this cube from the star, it no longer has the gravity that was once all around it from all the other mass, forcing it to stay this dense. So the moment I took it apart, it would expand and explode violently, like nuclear bomb stuff, but worse. So if you put that at the core of the planet, I have no idea what would happen. I don't know. There's probably a Kurzgesagt video about what happened if you nuke the core of the Earth or something.
Yeah.
But
it's not good.
It's probably not good, but I don't know the scale of this. I don't know how much you would need to affect the planet. The planet is huge. So I don't know how much neutron star material would need, but I do know, say, if you took this and you took it to a city and you let it re-expand, the city would be gone. Something like that. So it'd be very bad. Would it affect the core of the Earth? I don't know. It would be. That's hard to say. That would take real numbies.
Yeah.
Which I don't have. Numby boys. What's next?
From Gundam 5788.
This one? Gundam or
Gundam.
Cole?
That's Gangnam Style.
I know. I was hoping.
Wow.
If you could use one type of bending from Avatar: Last Airbender or Legend of Korra, which one would you want and why?
Sounds like a Kyle question.
This could be a you question. Airbending, waterbending, earthbending, firebending. What do you want? What do you want to control?
Ooh.
I mean, you already spit hot fire, but what would you? Well, what would you want to control?
I'd say water because of my fear of it.
What?
Fear of water. So I want to bend it so that I can bend it away from me, because no.
How many situations?
Water.
How many situations are you in where you wish you could bend water away from you?
Swimming in the ocean or the lakes, triathloning.
You want to part it like biblical style?
Yes.
So you can just walk
Bend that,
it?
yes.
Oh man, that sounds terrible. If you really could water bend, you could kill anything. And I don't think that's really I haven't watched all of the series, but I don't know if that's really established. Most living things are mostly water. And if you could control water and the movement of it, you could just hey, I'm not going to let any water molecules move into your cells. Or across, I'm not going to let any water in your body move across cell membranes. Dead.
Yep.
That would be horrible. So that'd be, I just thought of that on top of my head. That'd be a pretty rough one. I would like to, earthbending to me would be really cool.
For what purpose?
I would like to look at the side of a building and then raise a set of dirt staircase up from the ground and walk up to the top of the building.
That's not how you usually get to the top of a building?
Do you do that? Okay. Yeah, I would like to create mounds of earth for my own personal gain. Yeah, and like ramps for go-karts. What's next?
Just to let you know, the waterbending a person that is actually in the show.
Is it?
Bloodbending. That's what they call it.
Hemokinesis. Like Scarlet from Mortal Kombat 11. The science of Mortal Kombat now live. Yeah, hemokinesis would be bad. And I guess that's effectively the same thing. Controlling the flow of blood in someone's body, you can make them, I'm just gonna stop your carotid artery for just 5 seconds and you pass out and you're dead.
I would only use it for good, only for triathlons.
What, make it run quicker through your body? I'm so vascular right now. My blood's a pumping.
From Ben Lucas. What is light?
Old Ben Kenobi, Lucas?
Yeah.
Wow.
What does light move at different speeds through a vacuum than it does through water?
Ooh.
Your turn.
No, you seem like you want to hit this. Okay, go ahead.
I have an answer.
You get it.
I have an answer. Well, I mean, light in its fastest form, which sounds weird to say, but light in its fastest form moves 300,000 kilometers per second. So it's like 300 million meters per second. It's really, really, really fast. And light is at its fastest when it doesn't have to touch anything, when it doesn't have to interact with anything. So in theory, the fastest anything could go, not just light, is when it was trying to move through nothing. So when we say under vacuum, we mean that if light was moving through literally nothing, not even space is literally nothing, there's still atoms in space, just little bits of atoms and stuff. Little bits of lonely atoms here and there. So even in space, I think there's 1 atom per cubic centimeter or something, there's still stuff. So light in perfect vacuum moves at 300,000 kilometers per second, very, very fast. Now, why does it move more slowly through stuff? Which you're illustrating. Why does it move more slowly through stuff?
Because there's stuff for it to hit. The mean free path is shorter. That means the distance that I can go before I hit something else.
Yeah, the mean free path is very useful in nuclear physics, in gas physics, to say how long does one particle of something, whether it be light or atomic nuclei or whatever, how long distance-wise does it have before it, on average, interacts with something else? And like I said, this is very, very important in gas physics calculations and radiation calculations to see, like, if you're doing radiation therapy, you have to know what the mean free path is of different radiation that you're using to say, oh, will I hit this tumor and then it will stop? Or will I hit this tumor and on average it will go through my whole body and irradiate my backside? That's bad. So light has to interact with matter as it moves through it. It's not dark matter. So because it has to interact with it, it necessarily slows it down. And so that's why light will not go at light speed proper through something like water. And if you want to get less technical, like refractive indexes and stuff, light kind of has to take different paths through different density materials. You see that when light bends when it enters water, and so it necessarily is going to slow down. Yeah.
And you get a little color change too when it hits.
Exactly, and you bring that up because there is a weird phenomenon. You can actually see particles traveling faster than light does in a certain medium. It's called Cherenkov radiation. So if this was water, if this was all underwater, and you had a high energy particle emitted from a nuclear reactor, if it can be so high energy that it moves faster than light does in that same water. And when that happens, it excites the atoms so much, it emits a bluish, greenish glow. So if you want to open another window after this is done and look up Cherenkov radiation, you can see nuclear reactors in water, submerged in water so they don't irradiate everyone, off, and it's nothing, and then turned on, boom. There's a brilliant blue glow, and that's because things are traveling faster than light in that water because light is slowing down a little bit.
Very cool.
So many factoids I got
I
up here.
know.
I wonder what I've been forgetting.
Nothing.
From Shadowstorm 9119.
No, it's been people's birthdays and stuff. It's all.
For Dr. Moo, what is your doctoral thesis on?
Oh, that's a cool question.
Yeah, I don't even know
me either. No, I'm joking.
Me either. I'm a fraud. Hey.
I know. My doctoral thesis was in sterilization of spacecraft material using non-equilibrium, meaning the electron temperature and the gas temperature are not the same, atmospheric pressure plasmas. So what that means is Can I
take a guess? It means you were trying to study different ways of using really hot gases to burn all the microbes off of metal stuff.
And that's why this is Kyle's show.
Yeah, but what was there any interesting findings from that, or what was your conclusion, so to speak?
Yeah, so I had to understand the mechanisms. How do we kill these microbes? And I had to find the worst, hardiest microbes, things that live in the atmosphere, things that resist way more radiation than humans do. We die. So I took, extremophiles, that's what we call them, and I exposed them to plasma, and I found that, no matter how hardy you are, I got you. I can get rid of you.
That's pretty good. No matter what kind of life you are, I got some plasma with your name on it.
That's right.
I like that.
From BG.
That is pretty cool. The Bee Gees?
Yeah.
Gonna ask a question.
What would happen if a black hole crashed into another black hole?
This happened. This happens all the time in cosmic time. So I'm not technical enough to know what happens like nanosecond by nanosecond, but when two black holes collide, they basically merge their aberrations of space-time. So they become one larger black hole with more mass, and when that happens, it creates such a gravitational disturbance that it has waves emitted, as Moo is demonstrating, gravitational waves that are emitted. And that's because the ripple in space-time from this disturbance is so large, it creates something that's large enough for us to detect, and that's what the Nobel Prize you may have heard about was in LIGO.
Yes.
Light Interferometer Gravitational Observatory.
Yes.
LIGO, we nailed it. LIGO was trying to detect gravitational waves, and it needed an event large enough, like two black holes merging, and that's what happened. A disturbance in space-time so large that we could still detect it billions of years in the past, or its future, or you know what I'm trying to say.
Yeah. Shout out to the LIGO peeps. I mean, that was a huge amount of research that went into discovering this, so
yeah,
phenomenal.
Yeah, I remember when former President Obama was talking about it, even he was jazzed about it. He was like, so I heard two black holes collided, and then over here, things got a little bit bigger, stretched out. It's pretty cool. I was like, you know what? It is pretty cool. And then, anyway, what's the next, Nate?
From Game 007.
Game 007?
Yeah.
Shaken, whatever, I don't know.
Would an accurate Death Star laser melt a planet, burn a hole, or blow it up?
Accurate Death Star laser, what would it do to a planet?
Accurate, I mean, really?
It's a laser laser.
A laser laser. Lasers can do all kinds of things. All of the above, depending on how you tune your laser. You could likely get a laser strong enough to blow up a planet, but it takes a lot of infrastructure and planning to build such a laser. But, you know. You
say tuning. Could you tune it to ignore the atmosphere and hit the surface?
There are some.
Because I'm guessing it would just hit the top of the atmosphere once it's dense enough and create a kind of plasma explosion thing happening.
Yeah, so there is definitely some losses as you go through the atmosphere. That's why we have things called LIDARs. It's basically a laser that shoots either from the ground up or from a spacecraft down to understand the profile of the atmosphere, and it scatters in a way so that they can understand what it is. But yeah, there is some attenuation, some losses.
So it'd have to be even stronger than theoretical, like gravitational binding energy, which is what you see all the time. People will say it's 2 times 10 to that's 30. That's a 10. 32 joules is the gravitational binding energy of Earth, but it'd have to be even more because of the substantial losses that a laser would get just from entering the atmosphere of a planet, which is interesting. I never thought about it. And as it was creating that channel of plasma, as it was going down, it would disperse the laser energy even more. It's harder to go through plasma than it is through normal air.
This is true, but it'll look great as you're being destroyed.
I guess.
You get to see the plasma, all the colors.
Before you die.
I mean, side effect.
You said it was easy to make, too. I don't believe it.
It is.
Is it? Yeah. Oh, okay.
Last question.
Last question.
Okay.
From Tate Heil.
Tate.
If you could be in any cinematic universe, which and why?
Not bad.
Ooh, I would say which one I would not want to be in, which I love.
You
which is
take shots at it?
Wait, cinematic universe. Let me think.
Well, there's only one that's currently working.
The Marvels. Yeah, the Marvels. The Marvels.
Would it be that one?
No. I was thinking of a non-cinematic universe, a different universe of sorts.
Go ahead.
The Rick and Morty universe.
The Ricksterverse?
Yeah, the Ricksterverse. I would not want to be in that one because it's cutthroat. You got all the Ricks trying to go after you, and I don't know if I could survive.
Oh, jeez.
But it's the most entertaining, though. I love watching it.
No, I would be the DJ in the background of Blade 1. I would be DJ Bloodbath, and I'd be like, whoa! It's the first thing that came to mind. The original Marvel superhero in the MCU, by the way, Blade. He wanted to be in the MCU. Anyway, I would be DJ Bloodbath in the background of Blade 1, and she would be a background character in Interdimensional Cable 3.
Yes.
Because she doesn't really want to be there. like most of the skits there.
Yes.
Thank you so much, so much for watching another edition of Because Science Live. Thank you for watching everything on Because Science this week. The footnotes, the new episode about Tony Stark snapping the Infinity Gauntlet and what would actually happen to him. Spoilers if you haven't seen the video yet. And for this live stream, thank you so much, Dr. Moo, for being here with us. Again, I hope you liked asking us, and especially Dr. Moo, all your spacey questions. Hey, let us know if you like what we're doing here in the comments below, because right now, we don't have any super firm plans to do this all the time, but if you want Dr. Moo back, we can have her back as often as you'd want, and I love having her around. Also, speaking of Dr. Moo, on Monday we have the very first episode of Because Space going live with a very special celebrity guest in it that I'm super jealous about. And when I saw your face when you saw the final version of this, you freaked out for a while, and you're like, just turn it off, I can't handle it.
No.
It was great. So that is on Monday morning, the first episode of Because Space. Have a wonderful rest of your weekend. Next week, new footnotes, new live, new Because Science. And until then, be nice to each other. We're gonna duck out in a second. Be nice to each other, because this is all we got.